Hi, and welcome back to episode 7 of the Godot multiplayer series. Today we'll actually be covering cleaning up stuff on network connection and disconnection, so we'll be going deeper into those. So let's dive right in. First off, we're going to be on our network object script. Okay, let's scroll to the top here, and where we've got this validate ownership change callable, we're going to add a new callable called var validate destroy request callable, and this is going to be of type callable. There we go. Now, one thing I want this to do when players connect is I want it to sync the transforms so that we don't have that desyncing of like the server moved before the client connected, so they're like desynced. So let's sync those now. Let's make a function called func get transforms, and this will return a type dictionary. Okay, and then we are going to go var dict type dictionary, going to be empty, and then we're going to go var children is equal to a function we're going to make down here called get all children. So I'm just going to go down here, go func get all children, and then this is going to take in a node, type node, and it's going to return a array of nodes. So there we go. Okay, and I'm just going to pass from here for now. So this is going to take in the array type node from our function that we are going to make, where we will do get all children transforms of this node, so self, then we'll say for child in children, then we will loop through and say dict dot set child dot get path and child dot transform. And we're going to return this. It's going to return and return the dict. So there we go. That's that function done. Now we're going to make the get all children transforms. So when you get the children of a node, it only gets the immediate children of it. It doesn't get every single child that that node has. So we have to recursively get them all. So that's what we're going to be doing here now. So we're going to go var nodes, type array node, and it's going to be empty. And then for n in node dot get children. So if n dot get child count is greater than 0, so if the child has more children, then we'll say if n is node 2D or n is node 3D, so we're covering both 2D and 3D here, then we'll say node dot append or nodes dot append n, and then we will go nodes dot append array, and we'll call this function again get all children transforms, and we will get them for n. So that's if it has child, it'll get more childs and blah 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 blah. Cool. So now we'll go elif n is, well, we can copy this actually, nodes dot append n. Okay, and then last thing we got to do is return nodes. There we go. So now we've got all of the children transforms of a specific network object stored into a nice dictionary, and so that way we can send this dictionary over the network when we need to. So let's go and make a initialize function so that when a client connects, this network object will initialize and do all of that stuff of like syncing the transforms and everything. So we'll go at RPC authority. We only want the server to be able to call this. Call remote. Since the server already is the ground truth, it already knows where all the transforms are, so fine. Reliable, cool. And then we go func initialize, probably spelled that wrong, network object, and this will take in a owner ID int, and then so this will be the person who requested the spawn, or whoever it belongs to. This will take in a transform that of a dictionary, and then what we will do is we will go self.owner ID is equal to owner ID, and then we'll go var children transforms is equal to a array type node, and we will set this equal to get all children transforms self, and then we'll loop through. So for child in children transforms, we will go var child path is equal to child dot get path. Okay, and we'll say if dict dot as child path, then we will go child dot transform is equal to dict child path. Oh wait, whoops, transforms, not dict. Whoops, there we go. That's all good. And then once this is done, we'll actually go up here and we had this function or this signal on network ready emit. Well, now the network's not ready at this point, so we will take this down and put it here. So once we've synced all the transforms on initialize network object, we will emit this network ready. Okay, now for destroying objects, we will go at RPC. This will be of type any peer. We'll call local, and this will be reliable again. Oops, reliable. And now we're going to go func request destroy network object. This is gonna just take in absolutely nothing. We're good there. Okay, and this request destroy, so this is what the players will send to the server. The server can just call destroy because it's the server, but the servers have to ask to destroy things. So we're gonna go var sender ID is of type int is going to be equal to network manager dot multiplayer dot get remote sender ID. We're going to say if validate destroy request callable. So if we have this set and it's not null, then we will go if validate request destroy request callable dot call, and we're going to pass in the sender ID. So if this person can request to destroy it, so if we have a validator, and then if the validator returns true, then we will go and destroy. So I'll just say pass for now. And now we'll go else and destroy. So pass. Now let's make our destroy RPC. So at RPC authority, we want the server to be able to destroy things. Call local, and we will make this also reliable as well. And we'll go func destroy network object. So we'll say if it is owner or network manager dot is server. Remember, we registered this object only for the owners and the servers to the list of objects owned. We'll say if it's either the owner or the server, we will say network manager dot remove. Oh, I haven't made the remove, so pass. I am going to say remove network object from players object list, and I'm going to call this destroy network RPC here dot RPC. And here dot RPC. Cool. Do we have an on network destroy? Did I make this? Oh no, we'll make a signal too. Up here. So signal, I knew it. On network object destroy, and that's it. Now we're going to go down here and emit this. Emit, and then we're going to queue free. Cool. So now we need to go into the network manager and make this function to remove the network object from the list. And a couple other things, I think. Okay, let's edit this on peer connected function. Actually, first, let's go and make the functions we need down below, which is just the remove network object. So func remove network object, and this will take in a network object type network object, and we'll say for player in connected players, we'll go if player dot network ID is equal to network ID or network object dot owner, and we'll say if here player dot players objects dot has network object. So if it has the network object, then we will player dot players objects dot erase network object, and we will return, so we don't keep looping through. So there we go. We've got that function. Now let's scroll up to this on peer connected function. So when a player connects, we are gonna want to, so if a person just briefly disconnects and reconnects, we'll want to make sure that they don't have any leftover data stored. So we're gonna want to clear that out. So we're gonna go for player in connected players. If not is instance valid. So if the instance isn't valid of the player, then we will just go connected players dot erase player. So if it's not valid, if it's null or something, we'll just erase it from the list that we've got of players. And we'll say if player dot network ID is equal to peer ID, then what we're going to do is loop through and for network object in player dot players objects. So we'll loop through all of those. If instance isn't valid, I'll just change this here. Network object. Okay. If it's not valid, we will just continue. Okay. And then beyond that, we'll go network object dot destroy network object RPC. And we'll go down here and go connected players dot erase, and then we will erase the player. So that way we don't have duplicate. And then we will continue just in case there's multiple duplicates of this player. Now down here, we're gonna do another for loop. So we're gonna go for network object in player dot players objects, and we're going to go network object dot initialize network object dot RPC, and we're going to pass in the owner ID, so peer ID. Oh no, wait, not peer. whoops, network object dot owner ID, and then we're gonna go and take this network object and get its transforms dot get transforms. This get transforms, a good optimization we could do is to cache all the changed, like all of them at the start, and only send the changed ones that are different. That way we'd be sending less data over the network, but for now, this is fine. Now we've done this on peer connected. Now let's finish this on peer disconnected. So we'll go var disconnected player is of type connected player. Oh, got the D in that. Whoops. I've been doing that this whole time. Wow. I will fix that someday. So for player in connected players, if player in connected players, oh wow. If player dot network ID is equal to peer ID, disconnected player is equal to player, and then we'll break out of this loop. Now we'll go for network object in disconnected player dot players objects, network object dot destroy network object dot RPC. So destroy it for everyone if the person's disconnected. Now last step, connected players dot erase disconnected player. I'll see if it has it. If connected players dot has disconnected player, then I will do this. And there we go. Our disconnect function is done. Okay, I found a couple issues I had. I misspelled transform here, which caused it not to work. And I was also in the on peer connected, I was creating the player data, and then I was checking if the player data already existed here, and if it did, I was erasing it. So just move that to below this stuff, and everything should work from there. So I'm gonna run this, I'm gonna host, walk around, and then I will connect, and boom, it's synced correctly. All right, thank you so much for watching. Sorry about the issues in this episode. All right, thanks, bye.